Okay, I wanted to just continue with chapter 8 and just go over some of the concepts. And remember, this is just very surfacey. We're not going to get super detailed into probability. If you want to know more about probability, it'd be a good idea to take a statistics class. So let me share my screen. So we already went over the terminology. Okay, so we have the terminology in this is all chapter 8 of a probability of an event. We know that an outcome is the different things that can happen in the event. So for instance, if I had a fair coin, right, and I was going to flip a coin. Well, there's only two choices. I can either get heads or I can get tails, right? It's never going to land on its edge. So I literally have two choices that I can work with. Well, the notation for probability is capital P, and then in parentheses, it has a capital E right here. This E stands for event. So this is the probability of a simple event. So a simple event means something that happens and you get one outcome, right? There's one thing that's going to happen. It's not a combination. I'm not going to get heads, then tails, then heads. I'm going to just do one simple event. Okay. So for the simple event, if I want to know what's the probability of getting heads, right? So this value inside the parentheses can change. It just depends on what it is we're looking for. Okay. So if I want to know the probability of getting heads, the formula is it's the top number, or the numerator, is the number of desired outcomes. The bottom number is the number of total outcomes. Okay, so in this case, when I'm flipping a coin, I have two choices. So that is the total number of outcomes. The desired outcome is heads, and I only have one choice. So this is when I flip a coin one time. Now, probability is always going to be between 0 and 1. So 0 means there's no chance at all that it's going to happen, right? So if I said, what's the probability of the coin landing on the edge? It would be 0 because there's no chance that's going to happen, all right? That's 0. If I said, what's the probability of getting heads or tails? Well, I only have two choices, and so that's 1. That means there's 100% chance that I'm going to get a head or a tail. All right. In this case, I wanted just the probability of getting heads. So heads, I have 1 out of 2. So remember, this line in fractions is a division line. So 1 divided by 2 can be written as a decimal. All right. That is right in between 0 and 1. And then to change it to a percentage, you just move your decimal point over twice, and I get 50%. So this is the chance. I have a 50% chance of getting heads when I flip the coin once. My probability of getting heads is 0.5 or 1/2. So all of these mean the same thing. It's just how you're saying it in the sentence, okay? All right, so that's the probability of a simple event. So, and another example that you're going to see in my math lab is you have a circular spinner. It's divided into 12 equal sections. We have 3 red, 4 blue, 3 yellow, and 2 green. Consider the experiment of spinning the spinner once. Okay, so I'm just spinning it once, and we're looking for the probability of the spinner landing on blue. Okay. So the bottom number is the total number of outcomes. The top number is the number of desired outcomes. So I want blue, right? So I have 4 chances of getting blue. So now I'm going to reduce. 4 goes into itself once. 4 goes into 12 3 times. So the probability is 1/3. If I change this to a decimal, 1 divided by 3, you're going to see it's 3, 3, 3, and it continues on forever. To change it to a percent, it's 33.3, and then the bar means it continues on forever. Okay, so 33.3%. So that's the chance that I'm going to get the spinner to land on blue, or I have a 1 in 3 chance of getting the spinner to land on blue. So that's a simple event. One thing's happening. When you have what's called a compound event, I should have written that up here. I'm going to type that in. Probability of a compound event. Compound event just means that more than one thing can happen, okay? So what this is remember in chapter 7, we talked about union and intersection. So this is the probability of a union of two events. So remember this equation here, probability of A plus the probability of B minus the intersection. So remember, you're looking at a Venn diagram. If you want a picture of it, there's A, there's B. So the union is everything, and you're going to subtract off where it intersects. So here's the intersection. The reason you're subtracting that off is because this is already included in A, but it's already included in B. So you don't want to count the intersection part twice. So this is when you have, this first one is when you have an intersection, when there's something that's overlapping or that's in both sets. The mutually exclusive function is when they are completely separate. Okay, so that would be a Venn diagram that looks like this. So there's nothing that overlaps. Okay, so this is mutually exclusive. And this is when you have you know, one of the outcomes is overlapping. It'll happen in both. All right. So remember union. Union is this symbol. Union is used when you use the term or, and we're looking at the sum. So remember, sum is the answer to an addition problem. Okay. So you're going to see a Venn diagram like this in one of your MyMathLab questions. It's pretty straightforward. You can see that we do have an intersection here, an intersection of 25. So we're going to use the formula, the probability of A plus the probability of B minus the probability of A intersect B. Okay, so this is what you're going to see in MyMathLab when you ask to show an example. So now we're just going to go through and we're going to look at each section, right? We broke it down into parts. So the probability of A, well, the first thing we need to do is we need to find the total, right? That's our denominator. So when we find the total, that means we're going to add everything up, including the 35 that's outside. So we want the total of the universal. So 30, 40, 55, 65, 70 plus 30 is 100. So we have a total of 100 outcomes, all right? The probability of getting an A, okay, so it's in the A circle, so that's 55, right? So we have 55 out of 100, which is 0.55. The probability of getting B is everything in the B circle, which is 25 and 10. So we have, there's 35. So it's 35 out of 100, which is 0.35. Oops. And the probability of A intersect B. So now we're looking at just the intersection, just this section in here. So that's 25. So that's 25 out of 100, which is 0.25. Okay, so now we're set. We have all the values we need. Probability of A is 0.55. Probability of B is 30.35. And the probability of A intersect B is 0.25. And then you're just going to do the math. So the probability of A union B is 55 plus 0.55 plus 0.35 is 0.90, excuse me, minus 0.25, which is 0.65. So this is the probability of getting A or B. We have a 0.65 chance or 65% chance of getting A or B. Okay. All right. And then the last one, this is another example of what you'll see. That's my dog, sorry. coughing. So we have a cooler at a picnic. It contains 100 cans of soda covered by ice. There's 44 Cokes, 22 orange sodas, 26 ginger ales, and 8 root beers. The cans are all the same size and shape. If one can is selected at random, so this is a simple event, okay? Probability of a simple event because we're only picking one. So one can is selected at random. Determine the probability that it's ginger ale, root beer, or Coke. All right, so we want the probability of ginger ale or root beer or Coke. Okay, just putting it in symbols. So we always start with our total number of outcomes. So we have a total number of 100 cans. We have 26 cans of ginger ale. And remember, we're talking or, so this is plus, right? We have 8 cans of root beer. And Coke, we have 44 cans. Okay, so because it's or, right, we want this or this or this. So in other words, you don't really care what kind you get, just give me one of these. Then we just add the probabilities. So the add the desired number. So 26 and 8 is 34, plus 44 is 78 out of 100. So we have 0.78 or 78% chance of getting a Coke, ginger ale, or a root beer. Okay, all right, we'll stop there.